All right, welcome back. We are going to be doing chapter 8 with the videos, and we're going to start with the first two sections today, and we'll do 2 sections a day for the next 2 days, and it's about factoring. So we're going to talk about greatest common factors to begin with, and there's always 2 factors because you could always multiply like 1 times 2. Why is that doing that? 12 has more than those 2 factors. This could be 3 times 4. And 4 is not prime, so I'm going to keep going to 2 times 2. So we're talking about the factors of numbers. So like 12 is the same thing as 2 times 2 times 3. 10 is the same as 2 times 5. Both of those numbers are prime. And 25 is 5 times 5. All right, prime numbers, the only factor is itself and 1. So like 2, 3, 5, 7, 11, 13, and so on. And composite is everything else. Composite, it has multiple factors. So for example, 36, that is 6 times 6. 6 is not prime. That's 2 times 3 times 2 times 3. So the prime factorization of 36 is 2 times 2 times 3 times 3. So 24 would be, you can just start with 2 times 12. You could also start with 3 times 8. You'll get the same answer because 12 is 2 times 6. I'm going to circle my prime numbers. If I were to do it this way, 8 is 2 times 4, and 4 is 2 times 2. So regardless, 24 is 2 times 2 times 2 times 3. So that's the prime factorization of 24. So for 60, you could do 2 and 30. I see 6 and 10, so that's what I'm going to do. But it doesn't matter. You'll get the same answer. So go ahead and prime factorize this however you would like. And then your prime factorization should be 2 times 2 times 3 times 5. And 19 is a prime number. So that's just 1 times 19. Now, the greatest common factor is if you had something like 30 A, B, C. I just lost my 0. Plus 18 D, E, F. What's the biggest thing I could take out of that? What's the biggest thing I could factor out of it? Now, we can find that just by understanding the greatest common factor, or we could actually use the greatest common factor trees, which I'll show you. So 30 is 3 times 10, and 10 is 2 times 5. So 30's prime factorization is 2 times 3 times 5. 18's prime factorization is 2 times 9, and 9 is 3 times 3. So it's 2 times 3 times 3. Now, in common, these have 1, 2, and 1, 3. So the greatest common factor is the things that they have in common multiplied, so that is 6. So I could factor out a 6, and I would be left with 5, that's what's left in my 30, A, B, C, plus 3, D, E, F. So this is the exact same thing as this. It's kind of like factoring when you don't have that third term. It's factoring a binomial. And when you factor a binomial, two terms, you just take out the greatest common factor. So let's look at 24 and 60. So 24, we just did the prime factorization of that. We could do 3 and 8. And 8 I know is 2 times 2 times 2. And 60, we did 6 and 10. So we did 2 and 3 and 2 and 5. I'm going to put this in numerical order just so it's easier for me to circle the common things. So I have 1, 2, I have another 2, and I have a 3 in common. So my greatest common factor is the first 2, the second 2, and the 3. So my greatest common factor is 12. So again, if I had 24x plus 60y, I could take a 12 out, and I would be left with 2x plus 5y. And the 2 is this 2, and the 5 is that 5. Alright, so we're going to find the greatest common factor of 15x squared and 9x cubed. Now, are you at a point where we know that 15 is 3 times 5? If not, go ahead and make the whole factor tree. And we know that 9 is 3 times 3. And then we've got x cubed. We're going to circle everything in common. That's 1, 3, and 2 x's. So our greatest common factor is 3 times x times x. That's 3x squared. So if I had 15x squared plus 9x cubed, and I needed to put that into factored form, I would take 3x squared out front. I would be left with 5x, not x, just 5. I'd be left with 5, and then I would be left with 3x. This is the exact same as that. This is expanded form. This is factored form. So we're going to do the same thing with 16a squared and 9b squared. So 16, I think of 4 times 4. So 2 times 2 times 2 times 2, and then 2 a's. For 9b squared, 2 3's and 2 b's, there's not a single thing in common. So if you have 16a squared plus 9b squared, the only thing you can take out is a 1. And you're done. Okay, now we've got 3 things. So we've got the 6, which is 2 times 3. We've got 4, which is 2 times 2. And we've got the 12, which is 12 is 3 times 4. 4 is 2 times 2. So 2 times 2 times 3, 1x, 1z. Okay, so we've got a 2 in common for everything. And we've got an x in common for everything. And we've got, that's it. So if the equation that we had to factor was 6x squared y plus 4xy z to the 4th plus 12xz, you would take out 2x. And you would be left with 3xy plus 2yz to the 4th plus 6z. 2 times 3 times z. This is your greatest common factor. All right, so let's go ahead and factor these binomials out with the greatest common factor. In letter A, I can take a 2 out of both. So 2 times x squared minus 2. And we're done. In letter B, I can take an x out, and then I could take a 2 out. Let's just take a 2 out. Let's take a 2x. So you have negative 10 minus 8x. Now, 10 and 8 still have a 2 in common. So instead of taking a 2 out, I could have taken a 4 out, because another 2, if I take the 2 out of this and put it out front here, that means I could have taken a 4 out. So if I take the 4 out, I would have been left with negative 5x minus 4, negative 5, there's no x in the front, minus 4x. So if you can just see that and do that, that's fabulous. If you need to make the factor trees, that's fabulous also. No judgment. Do what you have to do to get these right. We've got an 18, a 6, and a 12. Those have a 6 in common. And we have 1x here, 2x is here, and 3x is here. I can only take 1x out because there's only 1x in common. So taking a 6x out of 18x cubed, I would be left with a 3x squared. Taking a 6x out of a negative 6x squared, I'd be left with a minus x. And a 6x out of the 12, I would be left with 2. And again, if you have a moment, go ahead and distribute that. Make sure you get this same answer, because this is expanded form and this is factored form. They're the exact same equation. All right, letter D. I cannot take anything out of that. There's not an x in common. 2 and 3 only have a 1 in common. So my factored form would just be 1. 1's my greatest common factor. Times 3x cubed plus 2x squared minus 10. And in the last one, there is a 1 in front of the x, if that helps make more sense of that. So I can take out an x. If you would like to make this a 1x, that's totally fine. So you would be left with 14x plus, Now, you have to have a placeholder there, because when you distribute this through, you would get 14x squared, but you need to get the 1x. So you need a 1 there as a placeholder to get that. So if the entire factor is the entire number, there's still a 1 left over. It's important. All right, in this situation, we're going to factor with this grouping. So do you see how this has an x plus 2 and this has an x plus 2? I'm going to take that x plus 2 out front, and then I'm going to be left with 5 plus 3x. If you distribute the first whole thing, you will get the exact same answer as distributing this. And we're going to focus on this factoring by grouping, because when we get to really difficult factoring, this is how we're going to do it. So in this next one, this and this are in common. Let me just take a little side note. Let's say we had TA minus 5a. So let's say instead of 3 minus x, that was an a. Looking at this, I can pretty darn easily see that a is what's in common, and I'm left over with a t minus 5. That's exactly all we're doing, but instead of a, it's a binomial, 3 minus x. And when I take that 3 minus x out, I'm left with my t minus 5. So this is pretty much the exact same as that. X plus 4 is the exact same thing as 4 plus x. So my x plus 4 is what is factored out, and I am left over with 5rs plus 3. And for the last one, there's nothing in common in these parentheses, so there is no grouping by factoring. That's just your answer. Nothing can be changed. So I'm now going to group the first two things together and the last two things. If you see something like you could group like these two together and then you could group these two together, if that is a nicer grouping, you'll get the exact same answer no matter how you group. So just for ease, I'm going to clump the first two and clump the second two. Now, my greatest common factor in the first two is 3a. And when I take a 3a out, I am left with 4c plus 7d. My greatest common factor in the second part is 2b. And when I take the 2b out, I'm left with 4c plus 7d. Now, do you notice that this parentheses is the exact same thing as that parentheses? So I can factor that out. And then I am left with, oh my, why is this not writing? Three a plus 2b. So this is my answer. Okay, the last problem. I'm going to group the first two and the last two. Just a little note, if this is a minus, make sure you make it plus a negative before you group. Otherwise, the negative would have to go through to like both things. Okay, greatest common factor here. I see an h cubed and a 2. So left over, we have 3h minus 2. Greatest common factor here, 4. Left over, 3h minus 2. Isn't that fancy how we keep getting the same thing in that parentheses? So 3h minus 2 is what comes out factored. And then we are left over with 2h cubed plus 4. All right, now this is the one small itty bitty tiny trick, and that trick is that these are so close to the same, yet they're not exactly the same. If I just look at 2 minus t, and if I factor a -1 out, I would have -2 plus t. So, if I make this a -6, I would have -2 plus t, which can also be written as t minus 2. So, I can make my parentheses the same by putting that negative out front. I can keep a plus in the middle if that's more helpful, plus a negative. And now I'll take out the t minus 2. And left over, we have 5 minus 6. Now, this is simplifiable, so we should simplify it. T minus 2 times -1. That's our factored form with our parentheses. This is our initial problem. They're the exact same. If you FOIL them or distribute them out, you'll get the same exact final answer. And in the last one, I'm going to group first and last. In the first, I have a 3x. Left over, that would be 5 minus y. So, I need to get a 5 minus y. If I take out a 4, I have y minus 5. If I take out a negative 4, I would have negative y plus 5. So I could rewrite this as negative 4 times 5 minus y. Or I could have rewritten this first one right here as negative y plus 5. It doesn't matter, either way. So now do you see how I can make those parentheses the same just with a negative? So my same parentheses comes out, and I'm left over with 3x minus 4. So that's my factored form. Another way of factoring. Have a great evening.